Can you solve this problem? Here we're being asked to describe the behavior of this rational function 3 over x minus 1 at the point x equals 1. To sketch this, think about the parent function 1 over x. To get 3 over x minus 1, we scale the function by 3, but we also shift the function to the right by 1. Therefore, our function should look something like this. Now that we have the sketch, let's check the behavior on the left and the right side of 1. As we approach 1 from the left, we see that the function tends towards negative infinity. Therefore, the limit of my function as x approaches 1 from the left is equal to negative infinity. We do the same thing on the right side, where as we approach 1 from the right, we see that my function tends upward towards positive infinity, so our limit on the right side would be positive infinity. And therefore, again, because the left and right side limits are not equal to one another, we'd say that the two-sided limit does not exist. Great, so we've gone ahead and described the behavior of my function by looking at the limit as I approach 1. We should note that while this sketch was helpful, it wasn't needed. By that I mean we could have solved these limits by thinking about what happens as I approach 1 from either the positive or negative direction. If I were to approach 1 from the left, I would be at a number slightly less than 1. A number less than 1 minus 1 would be a slightly bit negative number. So if you're going to divide 3 by a really small number, but it's slightly negative, that's going to push your values to very large negative numbers. Similarly, for a value that's slightly larger than 1, you would subtract something slightly larger than 1 from 1, you would get a number close to 0, but slightly positive. Therefore, if you take 3 and divide by a very small number that's slightly positive, that would push your value to be extremely large and positive, which is equivalent to our positive infinity.